Hi, my name is Mark Rand, Product Manager for AMG Advanced Microscopy Group. Today I'm going to show you how to unpack, set up, and use the Evos XL microscope. Unpacking the microscope is pretty simple. All you need to do is open up the tape using a knife like this. The power supply here and a cord, and this large piece of foam goes in. Now I can tilt the display back like this, pull straight up like this. And let's move over here and set it down gently on the table. And now I can just tip up the display like that, and we're ready to go. So the next step is to release the pin that's holding the stage. That's over here in this corner. To do that, simply pull up on the pin with the ring. And what we're going to do is store this pin, because whenever we transport the microscope, move it around the lab, if I were to put it inside the cell culture hood, something like that, we want to secure the stage so it doesn't move during transportation. Take it out, bring around over here, and now the power's connected. Now I'm going to open the accessories box here. This has the mouse in it and a few other spare parts. Open that up, and the mouse is in this bag. Go ahead and open that up. Let out a little bit of the cord here. Usually I let most of it stay trapped there like that. And then something I like to do is to take the pin and just slip it through here to keep track of it so it doesn't get lost before I plug it in. Okay, I think I'll put a mouse pad under here. This is the power switch. I'll just turn that on, and while the microscope is starting up, I can take our USB flash drive here, and you can also plug that into the side, like so. Before we use the microscope, I'll point out a few of the features so you can familiarize yourself with how it operates. Here's the screen, obviously, no eyepieces. There's software controls up here that we can operate using the mouse, and these buttons down here at the bottom of the screen. Looking down at the microscope further, there's a stage here that's, you can move it in the Y direction using these rollers. X direction you can move using this roller. You can also take the microscope and move it quickly from one location to another by holding these knobs and pushing. So you can go from this upper corner to this lower corner very quickly. If you have a microtiter plate, it's very convenient to be able to navigate quickly here and then make fine-tune adjustments with these knobs. This wheel down here in the front operates the objectives. So the objective turret is below, it's as it would be for an inverted microscope. We move the thumb wheel here and we rotate to a different position. You can see the objectives changing their position here. You'll also notice that up on the screen it's showing us the current objective that we're using. So as I click that into place, I know that I'm using the 20x objective. And if I move another position here, we're looking at the 40x objective. One last thing, the focusing wheel is on either side here. It's a single wheel. I can operate it with the left or right hand very comfortably by putting my hand down on the tabletop and doing the adjustment for focusing the specimen. Okay, now I'm going to put a sample on. I've got some cells that are fixed and that are in this microtiter plate, the 6-well plate. Standard microtiter plate fits into the opening on the stage perfectly without any kind of adapter. Put that in place, make sure that it's flat and seated properly. Now I can reach over with my mouse, move over here, and I'm going to turn on the light by clicking this button. The condenser light comes on up here, and we're now looking through the sample, through the optics to the camera, which is built into the base of the microscope. I can increase the light by dragging on this slider here, and you'll notice it's going to get brighter until it gets to the point where it's totally saturated. I can bring that back down a little bit until I get just the right amount of brightness. So I was using the 10x objective before, and it happened to be that the phase ring was matched already. If you look through this little port right here, you can see that it says 4x 10x. That's the phase ring that's matched to the 10x phase objective. If I change this to 20x by rotating the knob in the front here, I have to use a different phase ring to match in order to get the proper phase contrast. And that phase ring is adjusted up here in the top. I just rotate the ring here, and now if I look through there it says 20x 40x. In this mode I can move around and look at my cells dynamically, and if I want to say look at an area in higher detail, I can double click there and it zooms in, and now I've got a zoom factor of 2 on my live mode, and I can move around until I see something of interest. I'm focusing now by changing the focusing knob here, and when I get to the point where it looks pretty good, if I right click I can unzoom. I'm looking at the full field of view, and if that looks pretty good, all I have to do is click capture, and in a second or two we've got that full field captured and saved. After I've captured an image, I can actually zoom on it more than 2 times. So if I want to look at this cell in detail, I can just double click on it. Actually I can pick one up here, say, and it will recenter and zoom by a factor of 2 each time I double click on it. Say I want to look at this one in more detail. Double click, and now it comes to the center of the field of view, and I'm seeing it in very high detail. 8x zoom factor on a 20x objective. This is a digital zoom, obviously. If I right click, then I jump right back to the full-size image frame. I can also turn on a scale bar if I want to get an idea of the dimensions of what I'm looking at here. Under View, there's a button here that I can use to turn on the scale bar, and it puts a 200 micron scale bar here in this lower corner with this 20x objective. If I double click on an area, it also increases with the zoom factor. If I go up to this level, 4x, the scale bar fills up pretty much the full width of the screen, and if I continue to zoom, then the scale bar is not shown. In order to save, all I have to do is go here to the Save button, which you'll notice is in red. This indicates that the image has not been saved yet. So if I click on this button, what we get is a dialog for saving the file. It has the image file name here, and it has the file type in a selectable drop-down box here. Most of the time people will save it as a TIFF file, but you can also save as JPEG, bitmap, or PNG file format. If I want to change the name, I can click in this box, and what will happen is I get a virtual keyboard that pops up. In here I can add on characters. For example, I can put a dash and a number here to increment it each time I save it. Or I can select the whole name and change the name, image, and put in, for example, today's date by clicking on the date button. Once I've created the name here, I can click accept, and now that name goes into this dialog box. If you plug in a standard keyboard, you won't get the virtual keyboard popping up, but you can type in that box directly and then save it. So from here, I've selected my file format as TIFF. I click on Save, and the file is now being saved to the flash memory drive on the side of the microscope. You can also do Quick Save, and for Quick Save, I just check off this button here, and now this base file name is enabled. And every time I click on Save, it will save it with this file name and then increment that value, the last value, by 1. So if I click on Save here, it's going to save it as image 0001, and now the next time I save it, it will be saved as image 0002. If you're working with a lot of images and you're capturing images on the same sample repeatedly, Quick Save is a very handy way of keeping the base file name and simply incrementing that last number and saving them as a series of images that you can later understand as being collected all at the same time from the same sample.